Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video. And today we're going to learn about adding halogens to a pi bond. Very simple, fundamental reaction though. You're probably going to see it on exams, maybe more than once. So make sure you know it, okay? It's a very fundamental reaction. Before we get into this, please go ahead and slap that like button, leave a comment down below, subscribe to my channel. It is so helpful when you do that stuff, you guys. You have no idea. So please go ahead and do that. Help me grow my channel. Help me get my methods of doing chemistry out there to the masses so they can benefit as much as you are. All right? So without any further ado, let's get into this. So this mechanism is actually fairly odd, but fairly simple. So there's our pi bond. And let's make chlorine green. Why not? Oops, that's bromine. That's better. Bromine will do this too, by the way. But not iodine. So now, the pi bond will attack the chlorine. A lone pair from the chlorine will attack the other carbon. And this bond here will break. So let's go through that again. Let's just go through all the arrows again, because I know that this blew your mind, right? So the pi bond attacks the chlorine. So this bond here is saying, more or less, that this pi bond will attack the chlorine and make a sigma bond right here with the chlorine on it. That's what it's going to say, basically. We all know that will cause this bond to break. Okay, so that's going to happen too. So maybe the sequence is pi bond attacks the chlorine, this bond breaks. But at the same time all that's happening, the lone pair from the chlorine attacks this carbon. Because you're going to have a carbocation forming in proximity to a lone pair. Well, the lone pair is negative, right? So it's going to attack that positive. It's going to be slamming into each other. So it more than likely happens in a concerted fashion. It more than likely happens all at once. And that will form what is called the halonium ion. Now I'm going to draw it going down. It could be going up because you do form enantiomers in this reaction. And of course it's positive. There we go. So now, at this point, the other chlorine, which is now in the form of chloride, chlorine negative, attacks from the side opposite in an SN2-like mechanism. Okay, just like that. There you go. Oh, looking at the video, guys, I just realized that my green marker doesn't come through. It actually comes through as black. Okay, well, good to know. Still think it's pretty clear, though. So this is how this mechanism works. Now, if you have any trouble with this, just try it again. It's really not that hard. It's just right here when all this weirdness is happening, students get a little snaky. So all you got to think about is that the pi bond attacks the chlorine, the other chlorine leaves as chloride, and at the same time, a pi bond from the chlorine being attacked is attracted to this carbocation that's forming over here. I know it's a little weird, but you can totally do this. Now, if there's any other nucleophile aside from chloride or bromide, anything like that, you'll probably get attack from that species. Because remember, chloride and bromide, depending on how they're treated, aren't really that nucleophilic. Now, one question that I must address before I go, a lot of students ask, what's this? Carbon tetrachloride. Solvent. That's just the solvent. It doesn't get involved, doesn't do anything, so you can more or less ignore it. All right? Oh, and one other thing. You get the enantiomer. Plus the enantiomer. So you get this plus this enantiomer. All right? Pretty simple. All right, guys, if you found this video helpful, please go ahead and slap that like button, leave a comment down below, and subscribe to my channel. It really does help me out as a YouTube creator when you subscribe, like, and share my content with your family and friends. So with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.